Hello, geometry students. We'll be looking at lesson 3.2, which is proving lines parallel. In the previous lesson, we talked about parallel lines. We actually first just talked about any two lines cut by a transversal. They don't have to be parallel, and we had a lot of different angle pairs. And we're going to be discussing those angle pairs today. But yesterday when we discussed this, or last class when we discussed this, we learned we started with if two parallel lines are cut by a transversal, then we had a few different things. We had one, which actually was a postulate. We had corresponding angles are congruent. We had alternate interior angles are congruent. We had alternate exterior angles are congruent. And we had consecutive interior angles are supplementary. What we're going to do today is we are going to look at the converse of many of these, the converse. So we're actually going to start with just two lines are cut by a transversal, and we might know that corresponding angles are congruent or alternate interior angles are congruent or something else, and therefore the lines must be parallel. Well, so we're going in the opposite direction. So we're kind of just starting with any two lines cut by a transversal and then some more information, and we're trying to show that they are parallel instead of starting with the fact that they are parallel. So a lot of these terms will be familiar because we just discussed them in the last lesson. So here's the first one. This is the converse of the corresponding angle postulate. And so it's actually written as an if and only if statement now. So two lines cut by a transversal are parallel if and only if corresponding angles are congruent. We're actually going to skip this example for now and look at a couple of these other things. As you notice, there's a lot of converses here: alternate exterior, converse of the alternate interior, converse of the consecutive interior angle theorem. And let's just notice each of these real quickly. They're all very similar. They all start with if two lines are cut by a transversal, if two lines are cut by a transversal, if two lines are cut by a transversal, so alternate exterior angles are congruent, or so alternate interior angles are congruent, or consecutive interior angles are supplementary. If you know that one of those things are true, then the lines must be parallel. So again, it's the converse of the ones that we talked about before. So instead of knowing they're parallel to start with, we're trying to show they're parallel if we know corresponding angles are congruent, or alternate interior or alternate exterior are congruent. And then this last little theorem here, maybe not the last, but the converse of the perpendicular transversal theorem. We learn that after we learn the other few things, but it says, if two lines are perpendicular to the same transversal, so we're going to draw a line that's going to be perpendicular to a transversal. And then we want another line that's also perpendicular to it. So that's this first part. If two lines are perpendicular to the same transversal, well, what has to be true? Well, they have to be parallel lines. Those two lines must be parallel. And we can prove that pretty easily using the things above. Let's jump back to this example one now. We'll see things written like this in other problems. Find the value of x that makes line A and B parallel. Well, in order for line A and B to be parallel, corresponding angles could be congruent. So what we do, we still solve these similar to what we did before. We would say 6x minus 8 is equal to 4x plus 17. Because if these corresponding angles are equal, then the lines will be parallel. And so you go ahead and solve these. We get 2x minus 8 equals 17. Add 8 to both sides. So 2x equals 25. And then divide both sides by 2. And we get x equals 25 halves, or 12 and a half, 12.5. We have a couple other things here that we can look at. The transitive property of parallel lines. If two lines are parallel to the same line. So let's start with our same line. So we're going to say, oh, well, this line is parallel to our original line. And then this third line is parallel to our original line. What has to be true about these two lines, this one and this one? Well, they have to be parallel. And then example 3. Which lines can be proved to be parallel from each given statement? State the postulate or theorem that justifies your answer. So we're going to look at each of these individually. One doesn't have to do with the other. So we have our figure here with lines A, B, C, and D. And we know angle 1, or if we know angle 1 is congruent to angle 2. Well, here's angle 1, and here's angle 2. Well, if we look at that, that's parallel lines. Sorry, not parallel. We don't know they're parallel yet, but we have two lines cut by transversal C. If angle 1 and angle 2 were congruent, lines A and B would be parallel because those are alternate interior angles. So this would be A would be parallel to B if angle 1 and angle 2 were congruent. And that would be, by this third one here, the converse of the alternate interior angle theorem. So we'll alternate interior angle theorem converse. All right, I'm going to erase, get a clean slate here. Let's take a look at the next one. What if angle 2 is congruent to angle 3? Here's angle 2, if that's congruent to angle 3. Well, what we want to do is we want to kind of highlight what's forming those angles. So angle 2 is formed by this line, so line C and line B. And then angle 3 is formed by line B and line D. Well, looking at that now, angle 2 and angle 3 are alternate exterior angles, so if they were congruent, line C would be parallel to line D. And that would be the alternate exterior angle theorem converse. Let's start again, erasing these things, and let's look at the last one. Measure of angle 5 plus measure of angle 6 equals 180. Well, that's these two angles, measure of 5, measure of 6. Let's see what forms angle 5. Angle 5 is formed by this line, line D, and line A. And then angle 6 is formed by line B and line D. Well, we see that 5 and 6 add up to equal 180, which means angle 5 and 6 would be supplementary, and they are consecutive interior angles. So we could say line A is parallel to line B by the consecutive interior angle theorem converse. And then going back up to this last example, prove the converse of the perpendicular transversal theorem. They actually start us off here. They have the figure and the given and prove. So it says, we have our statements here and our reasons. We obviously can put our given first. And that's marked there already, that A is perpendicular to T. I wrote this wrong. This should be a T. And B is perpendicular to T. Well, what does it mean to be perpendicular? Well, if two lines are perpendicular, they form right angles. So we could say angle 1 and angle 3 are right angles. We know that because that's the definition of perpendicular. So you need to know this symbol here means perpendicular. And early we learned that all right angles are congruent. So we can say angle 1 is congruent to angle 3 because all right angles are congruent. That was a theorem we learned. They're congruent because they both will measure 90 degrees. And then lastly, we see angle 1 and angle 3. By looking at them, we see that they are corresponding angles. Well, if corresponding angles are congruent, then the lines are parallel. So A is parallel to B, and that is from this first one up here, the converse of the corresponding angle postulate. And so we can write the corresponding angle postulate converse. And there you have it. So there are those different ways to prove that two lines are parallel.